So in this video, we're talking about solving quadratic equations by taking square roots on both sides. Alright, so what's a square root? Well, a square root is just another operation, but essentially what we're doing is we're looking for two equal parts that we can multiply to get to a desired number. So for instance, what I'm saying is, if I take the square root of a times the square root of a, I have two equal parts. These two numbers are exactly the same. Well, then what I should end up with is just a number. So I could take this number and break it down into two equal parts, and that's all it is. That's the definition of a square root. And then how do we find the square root? Well, for instance, let's say if we're looking for the square root of, I don't know, 81. Well, we know the square root of 81 is 9. Okay, but what we're doing is we're looking for two of a kind. So I'm just going to break this down to its nice factors. So 9 and 9. 9 times 9 is 81. These two are the exact same number, so it follows this rule. 9 times 9 equals 81. So this is square root, so the square root of 81 equals 9. That's all it is. That's how you find the square root by hand. Now obviously if you have a calculator, it's a lot easier. Just type it in, calculate. The only issue you might run into is, do you need to simplify the square roots? Okay, and then what's the product property? So product property is pretty easy for square roots. All it is saying if we have two square roots that are multiplied together, then we can put the radical of the number on the inside of each square root. Let's make this two separate numbers. So I have the square root of a times the square root of b. I have two separate square roots. What the product property tells me is I have a square root times a square root. Well, these two numbers on the inside, I can put them together on the inside. So square root of a times b. Just like that. And quotient property works out pretty much the same way. So I'm taking the square root divided by the square root of a number. So I have two separate numbers that I'm taking the square root of. I'm dividing. Well, quotient property just says I can just take the square root, put both numbers on the inside, and then do my fraction, and then do the square root last. Now, a lot of people, when they see equations like this, they go from left to right. Well, you have to remember equations also go from right to left. So if I start off with this, I can split it up into two separate square roots if I need to. Same thing with the quotient property. It goes from right to left also. If I start off with something like this, I can split it up if I needed to. Okay, so I just want to go through and simplify these. All right, well, 24. Looks pretty nice, but I'm going to split it up. I know it's 24. Do some scratch work up here. 24 can be broken up into 6 times 4. So that's what I'm going to do. So using my product property, I have square root of 6 times 4. But I want to split this up now. So I have the square root of square root of 6 times the square root of 4. And then I can go through and simplify. Square root of 6, I don't know, and it also cannot be simplified any further, so I'm going to leave that alone. And then square root of 2, our square root of 4 is 2. So I have 2 times the square root of 6. That's as much as that can be done there. Now, if you were using your calculator and just said simplify, you plug it in, hit enter, you're going to get a nasty decimal. Well, same thing. If you plug this in exactly the way it looks, you're going to get a nasty decimal. What's special, though, is that this decimal should match up exactly with this decimal because we simplified it correctly. Okay, down here, let's do square root of 6 times square root of 15. Well, unfortunately, I don't know the square root of either of those numbers, so I can't simplify the way it's written. So I'm going to use the product property. The product property says I can just put these two numbers together inside the square root. So 6 times 15. Okay. All right, well, I just need to go through and do this now. So square root of 6 times 15, that's 90. And then I want to go through and break that down as much as I can. Well, we need to do a little bit more work because I don't know square root of 90 off the top of my head. So I'm going to do some scratch work. I know 90 can be broken down into 9 times 10. 9 times 10. So I'm going to break this up into square root of 9 times 10. I'm just using the product property to split it up again. So just like we did in the first example, I have square root of 9 times square root of 10. And I do know square root of 9, that's 3. So 3 times the square root of 10. Very, very simple. Okay, notice I did have to do a little bit of scratch work with this one, no big deal. All right, and then finally, simplify square root of 7 over 16. Well, this is using the quotient property. I don't know what that fraction is off the top of my head without using a calculator. And even if I did use a calculator, something tells me it wouldn't work out very nicely. So what I'm going to do is just use my quotient property to split these up. So I have the square root of 7 over the square root of 16. Square root of 7 I don't know, so I'm just going to leave that alone. But square root of 16 I do. I know is 4. So square root of 7 over 4. And that's as much as that can be done. Okay? And then finally, the last one on the bottom, I have square root of 7/2. Well, I'm going to start off with my quotient property again because I don't know what the square root of 7/2 is. So I have square root of 7 divided by square root of 2. Well, unfortunately, I don't know the square root of either of those numbers. Square root of 7 is a really nasty decimal. Square root of 2 is a really nasty decimal. So for now, I'm going to leave it like this. Notice that I said for now. Okay? I thought I had another slide here, but apparently I don't, so let's go back momentarily. Now, technically this dumb answer is correct down here, square root of 7 over square root of 2, but we can clean it up a little bit more. I thought I had another slide to do this work on, but I don't, so we're just going to come back here and do it. So what we're going to do is something called rationalizing. And essentially what it means is I want to get rid of that square root on the bottom. This is typically an American idea. Over in Europe, this answer would have been totally acceptable, but the American idea is we want to make it look as clean as possible, so we don't like square roots on the bottom. That's just kind of a standard rule that we've all accepted. So what I want to do is I want to try to do something to get rid of that square root on the bottom. It's pretty easy to get rid of that square root on the bottom, actually. All I'm going to do is, whatever square root is on the bottom, I'm going to multiply the top of my fraction and the bottom of the fraction by that square root. So let's say I start with square root of 7 divided by square root of 2. Well, to get rid of that square root, I'm just going to multiply by square root of 2 over square root of 2, because that's the square root that's on the bottom. That's what I'm trying to get rid of. Okay, well, I have two fractions now, so when we multiply fractions, we multiply straight across. So I have square root of 14 on top of square root of 2 times square root of 2. Well, this goes back to our rule that we talked about at the beginning of the video. I have two equal parts, and they equal the number. So square root and square root, they cancel each other out, so I'm just left with 2 on the bottom. So I'm just left with the square root of 14 over 2. Now, you might be like, well, how does this work? How come I'm not changing the value of the fraction? Well, what's happening, if you notice, I'm multiplying by square root of 2 divided by square root of 2. And we know anything divided by anything is 1. Or sorry, anything divided by itself is 1. So essentially all I'm doing is taking my original fraction and multiplying it by 1. Now that 1's just kind of camouflage. It doesn't look like a 1, but it is. Okay, so I haven't changed the value of the fraction at all. So this will come out to a certain decimal, and this will come out to the exact same decimal. These two fractions are equivalent. So either form of this answer is okay. This is typically the European way we would answer. This is typically the American way we would answer. For me, I'm fine either way. All right, now let's move forward. Okay, so we're talking about how can we use square roots to solve quadratic equations. So let's go on and do an example. Here, the name of the game is we want to get our x squared piece by itself. Okay, you always got to get that piece by itself first. So I'm just going to go ahead and start solving like we normally do. So minus 1. So 2x squared equals 16. Okay, now divide by 2 because I'm still trying to get x squared by itself. So x squared equals 8. All right, now that I got x squared by itself, I need to get rid of x squared because I want x. So to get rid of square, I got to take square root. Those are opposite operations. So I'm going to take square root on both sides. Square root on both sides. Now I've forgotten something here. Notice this number 2. Well, that tells me how many answers I should have. Right now I only have one answer. So what I'm going to do to fix that, I'm just going to put a plus or minus out front. Plus or minus out front. Square and square root cancel out, so I'm left with this x equals plus or minus the square root of 8. Now you can leave your answer like this, or you can split it up into two separate pieces. So x equals the positive square root of 8. Notice I didn't have to write the plus sign in front because it's understood to be positive. And x equals the negative square root of 8. Okay, so you can split it up into two answers. Here my power was 2. I ended up with two answers. Okay? Now, anytime you're taking square roots to find your answer, you need to double check to make sure that your answers work in the original equation. Because sometimes what we'll get is called an extraneous solution, meaning we'll get an answer, but it might not necessarily work. We might get something bad happening in our original problem. So what you should do is take these answers and plug them back into your original problem. Everywhere you see an x, plug in. Okay? So I'm just going to do that real quick so you get the idea. So I have 2 times square root of 8 squared plus 1. And if it works, it should be equal to 17. All right, well, I know square and square root cancel out, so I have 2 times 8, which is 16, plus 1, and that does equal 17. So this one does work. I also need to check this second one. So 2 times the negative square root of 8 squared plus 1, and if it works, it should equal 17. Okay, well, first off, I have square and square root cancel out, and then negative squared, negative times negative is a positive. So I have 16 plus 1 equals 17. So this one also works. So no extraneous solutions in this problem. So the point is, every time you take square root, you need to check your answers. Most of the time it'll work, but sometimes it won't, so be careful. Let's try another one. Again, this looks really bad, but what we need to do is get that x, to get the piece that's square, get that by itself first. So the first thing I'm going to do is get rid of this fraction. So to do that, I'm going to multiply by 3 on both sides. So 3, and what I do with one side, I have to do to the other. So here, fractions cancel, so I just have x plus 5 quantity squared is equal to 21. Okay, well, I don't want a squared. I want to get rid of that. So to get rid of that squared, I've got to do square root on both sides. And don't forget, since I have square, I have 2 answers, so I need my plus or minus. Okay, square root and square root cancels out, so I'm just left with x plus 5 is equal to plus or minus the square root of 21. Well, at this point, you can split it up into 2 separate equations if you prefer. Okay, so I'll go ahead and do that. So you have x plus 5 is equal to the positive square root of 21, or x plus 5 is equal to the negative square root of 21. Now you can go through and solve either of these. Just get x by itself by subtracting 5 from both sides. So minus 5, minus 5. Now these are not like terms, so everything's just going to fall down. So I just am left with x equals negative 5 plus the square root of 21. That's one of my answers. And then down here I have subtract 5, minus 5. Again, these are not like terms, so my second answer is x equals negative 5 minus the square root of 21. That's my second answer. Okay, so so those are my 2 answers, or I could just stay over here like it is. I could just subtract 5, cancel out. Again, not like terms, so x equals negative 5 plus or minus the square root of 21. Like that. Alright, so over here I showed that, hey, I could split my answer up into 2 separate pieces if I want to. Totally fine. Or you could just leave it like this. Just don't forget that plus or minus, because that plus or minus represents both answers. Okay, that's it for this video. Thank you very much.